By request 11177 is we're asked to prove or show whether the following sequence, which is 3 minus 2n over e to the n, is increasing, decreasing, and if it's bounded. And as a result, they don't ask this if it's convergent. So the first thing I'm going to do is showcase that this is either increasing or decreasing. I'm going to let f of x be the functional version of this, 3 minus 2x over e to the x, which will imply that f prime of x is equal to, let's see, a negative 2e to the x um, minus 2x e to the x all over e to the 2x. It's just a quick derivative there. I'll factor a negative 2e to the x out of numerator and simplify all at the same time. So you get this. And that f prime is, let's see, negative times, when x is greater than 1, that's going to be negative. So f prime is positive for all x greater than 1. And so, therefore, we know that f is increasing. And that implies that a sub n is increasing. So now that I know that a sub n is increasing, I'll go ahead and highlight that. It's increasing monotonically, by the way. And so now that I know that a sub n is increasing monotonically, I know that its lower bound will occur at its initial value, right? That's the lowest value. So a sub 1, which is 3 minus 2 over e to the first, is the lower bound. So it is bounded below. And now to find an upper bound, I'm going to go ahead and take the limit as n goes to infinity of our sequence, which is 3 minus 2n over e to the n. Because I'm going to use some calculus here, I'm going to convert that actually over to a function. So I'm going to write this instead as a limit as x goes to infinity of 3 minus 2x over e to the x, because the calculus I'm going to use is L'Hopital's rule. And so because I need a continuous function to use L'Hopital's rule, I need my variable to be continuous. So let's see, this is going to be 3 minus 2 times the limit as x goes to infinity. Derivative of the numerator is 1, derivative of the denominator is e to the x, and you can see that tends to 0, so that's just 3. So this is an upper bound. So let's see, our sequence is monotonically increasing. I'll highlight that. I guess I didn't highlight that. That was supposed to be a highlight. Anyway, it's monotonically increasing. It has a lower bound. It has an upper bound. Therefore, it converges, even though they didn't ask us that part.